Even send you an SMS regarding this increases as we progress. RAM of 128 megabytes for Windows operating system. And the following browser version supports Java: Firefox 3.6 or above, IE 7.0 or above, and all versions of Chrome supports execution of Java. And these are all various Windows operating system versions that support running of Java program. If you've been using Mac, then apart from the above mentioned hardware requirements, you need to make sure you have an Intel-based Mac OS X of these versions and a 64-bit browser. You may run into problem if you have old MacBooks with PowerPC. So if you purchase your Mac, so more the language is closer to human natural language, the slower it becomes. C++, Java, PHP are some of the examples of high-level language. Tip number 2, practice. Requirements: there are a few software and hardware requirements, termed as system requirements. If you've been using Windows operating system, then these are the million-dollar question: what is Java? The simple answer would be Java is a programming language and a computing platform. So what exactly does that mean? Let us first understand what platform is. Let's say you bought a new computer, and as a friend of yours, I give you a few softwares and games. I give you one Photoshop, Chrome browser, and Need for Speed racing game. Would you be able to install these softwares or play games? No, because your softwares does not know your computer and your computer does not know your softwares. The name changed from JDK to Java to Standard Edition, or J2SE in short. And from release 6 to 8, it's simply Java SE. Now although we can spend some time in knowing the features introduced in each one of these releases, I feel it's not worth the time, as we have a lot of good concepts to cover. Let's preserve our brain for some interesting concepts which will come shortly. Now your computer will run it and show the output you're expecting. It will be 30 and will be displayed on your screen. And it's mere understand 10 electronic devices. But in the meanwhile, there was a huge demand for the platform independence even for internet applications, because internet was booming by that time. So now obviously all that green team had to do is to say goodbye to a small set of programmers for electronic devices and say hello to web developers. Since then, Java started advertising itself as Vora, which means write once, run anywhere. And obviously this has attracted a lot of frustrated programmers and contributors. In 1995, Java was first made available to public. The main intention was to get a direct feedback from programmers and general public. Z interpreter. We're glad that Java is considered as high-level language though. So more the language is closer to human natural language, the slower it becomes. C++, Java, PHP are some of the examples of high-level language. Coming to low-level language, these are somewhat closer to machine language, I mean zeros and ones, and hence humans find it difficult to understand and to code. These languages are often dependent on platform, so the developer have to keep in mind on which operating system he is really willing to run his program. So if he writes a piece of code for Windows, there is no guarantee that it runs on Linux. Developers have to amend the code to get it working for all operating systems. And since these languages are close to machine-readable language and mile away from humans, they run faster compared to high-level languages. Assembly language is one good example. And middle-level language lies in between high-level language and low-level language and are neither close to human nor computer. They stay in between the two. A good
Hello everyone, and welcome to an introduction to data structures.
Requirements. You need to make sure you have an Intel-based Mac OS. We're glad that Java is considered as high-level code or intermediate code. Just-in-time compiler. Now you will better understand what just-in-time compiler is. Let's have a small program. Here, as you can see, that we're having 5 statements or 5 lines of code, out of which 3 of them are redundant. The statement display Z is written 3 times. The compiler will compile the code and generate intermediate code. Let's assume this is the intermediate code. Now when we run the program, the interpreter translates line by line and your computer runs them as and when it gets translated. But one interesting thing about this is that the computer will have to wait every time the interpreter translates each line. Whereas in case of compiler, there is no wait time, as the computer will get the fully translated file in one go. In this scenario, although we cannot nullify the wait time, at least we can reduce some impact using a technique called just-in-time compilation. The compiled code or intermediate code will go through the just-in-time compiler so that it will further optimize it. In this case, line 4, 5, 6 are redundant, and just-in-time compiler will mark this code as redundant. So when the file gets interpreted, the interpreter will now know that the code in line number 4 is going to come again. So it stores the machine code of line number 4 somewhere in the computer memory. And whenever it comes across with the same piece of code again, it will simply tell the computer to run machine code directly without translating. So there is no retranslation of same code again. This phenomenon is called just-in-time compilation, and this will significantly improve the performance. In reality, just-in-time compiler and interpreter will go hand in hand in Java and use even more optimizing techniques to increase the performance. So just remember, both just-in-time compiler and interpreter will come into picture only when you run the program. Now I hope I made myself clear in explaining what compiler is, what interpreter is, what just-in-time compiler is. If you're still unclear about any of this, don't panic, it's very normal for beginners. Just try to view the video once again. If you still don't get it in second time, no need to worry again. Just move on to my next videos and revisit this video later. Okay, we've been hearing terms like JDK, JVM, JRE, and there are a dictionary of such words which kept annoying us. Now let's try to uncover a few of them. We've already talked about JVM and just-in-time compiler in our previous video, so I'm not going to talk about it again and waste your precious time. But one thing which I wish I should have mentioned you in my earlier video is JVM have multiple vendors. Sun Microsystems has their own version of JVM. Similarly, there are some other vendors who claim that their JVM is better than their competitors. So each JVM is different. Some may use interpreter, some may use compiler, and some may use both. So if you got people saying JVM uses only just-in-time compiler or only interpreter, they are all correct because each vendor is having their own implementation of JVM. Okay, let's move on. JRE stands for Java Runtime Environment. The word itself says it's a runtime environment, which means JRE helps run the Java program or .class file to be specific. JRE is actually a collection of few tools, utilities, runtime libraries, and JVM, which together help run the Java program. If you just want to play games or use Java applications, you just have to install JRE. But JRE does not let you develop any Java programs. For that, you need JDK, stands for Java Development Kit. It has all the tools and utilities to help you write, debug, compile, and run the Java program. You're already aware of one of the tools that JDK has, the Java compiler. It also has debugger, which helps in detecting the bugs in your code, and a few other useful utilities. It also has JRE for you to run the compiled program. So yes, if you install JDK, it comes with JRE. So you don't have to install JRE separately. Okay, that's it. Let's keep things simple for now, as we are definitely going to uncover some of the interesting and annoying terminologies as and when we come across with them.
It's time to install JDK on our computer so that we can start writing Java programs. Installing JDK is same as installing any other software. What are you waiting for? Go ahead and install JDK. Okay, relax. Let me help you out. Visit their official website. That's www.oracle.com. Click on this menu. Locate the downloads link. Click on it. There are quite a lot of softwares offered by Oracle, but the one that we're interested in is Java. From this list, we want to download Java Jdk for developers. We don't want to download JRE, which is a runtime environment. And as we had discussed before, if you install JDK, it comes with JRE. So let's click on this. And then download JDK. I've already done that. I don't have to do it again. Once you have this executable, just double click it. You may get a prompt that looks something like this. Here is the installation directory. If you'd like to change it, you can change it. But I would recommend you to just leave it to the default and click Next. It's going to take a while, so let me pause the video and then get back. Okay, we have successfully installed JDK on our computer. You can just close now. And if you go to the installation directory, you should be able to see all these files. In our next lecture, we're going to write our first Java program.
It's time for our first Java program. In this video, we'll write a Java program and run it. Let's take a look at the steps that we need to follow. Let me open up the notepad. Step 1. Write the source code on a text editor. Step 2. Save the source code as Java file. Step 3. Compile the source code and generate object code or intermediate code. Step 4. Run the program and display a message. Step 5. Get a sense of accomplishment. Okay, let's go step by step. Now, what I suggest you is don't just sit and watch me do this. Follow along and do exactly what I'm doing. This will help you even if you're an experienced Java programmer. So step number 1, write the source code on a text editor. I'm using Windows operating system, so I'm going to be using Notepad for this purpose. If you're using any other operating system, you can use something similar to Notepad. So let's open up Notepad and write our source code. Class, first app, opening and closing brackets, public static void main, and within the brackets string args. Make sure that you take care of uppercase and lowercase letters. For example, if you type string with lowercase s, your program will not work. Just type exact same code. You don't have to try to understand this code, but just write it. System.out.println, and then you give your message here. I'm going to be giving AP. It's working. Now all we're doing from this program is we're trying to show a text. So when we execute this program, we should see this string. AP, it's working. But before that, let's go to step number 2. Save the source code as Java file. Let's do that. So what we have here is the source code. Now to save this file as Java file, we need to append .java at the end of the file name. So we go to File, Save As, and type in firstapp.java. Make sure the name of the file is same as the name of the class. If you want to know why it has to be same, maybe the answer would be too advanced at this moment. But as a rule of thumb, always give your class name as file name. Let's save it in desktop. So we got our file created here. This is a Java file now. Let's move on. Step number 3. Compile the source code and generate object code or intermediate code. For this purpose, we're going to be using a tool called Java C, which is a Java compiler. This comes with JDK. So let's open Windows command processor by hitting Windows key and then letter R, and then type in CMD. Hit enter or press OK. Now let's navigate to the location where Java C tool is residing. So we go to CD is a command used to change the directory. CD stands for change directory. And then we go to C, program files, Java, JDK, and then we go to bin directory. Hit enter. Let me show you the tool that I've just talked about. Let's run dir, which shows list of directories and files in the current directory. So we should see Java C here. So here it is, javac.exe. Now we're going to be using that tool to compile our source code, which is in desktop. We type in Java C and then the absolute path of the Java file, which would be C, users, admin, desktop, firstapp.java. Let's hit enter. This should compile our source code and generate intermediate code. Let's verify if it has done that. We see a new file generated. This is nothing but the intermediate code that JVM can understand. Now let's move on to step number 4. Run the program and display a message. For this purpose, we're going to be using another tool called Java. So Java is the name of the programming language, Java is the name of the technology, Java is the name of the platform, Java is also the name of the tool used in JDK. So don't get over confused. Let's go to command processor. Luckily, Java tool is residing in the same folder, so we don't have to navigate to some other directory. So I type in Java, and then we need to specify the location of the class file by specifying class path. So that CP stands for class path, and the location of the class file is desktop. So let's specify that. C, users, admin, desktop. Now we specify the name of the file, which would be First, app. You don't have to specify .class here because the tool Java is going to consider only class files. Now, if we run this, we should see our message. It worked. We see the message EP, it's working. Let's go to step number 5. Get a sense of accomplishment. I hope you're feeling so. Now, I'm pretty sure that you might be having questions like, what is this public? Why do we need to write so much of code just to display a simple message? Isn't there a single command that helps us compile and run together? For all such questions, ladies and gentlemen, welcome to Java World. Now, every time you want to compile and run the program, you need to navigate to this bin directory in order to access these tools, Java C and Java. To ease our job a little bit, Windows operating system lets us configure path variable. Let me show you what I mean. You right click on computer, click on properties, and then you go to advanced system settings, click on environment variables, and then we're going to be specifying a new user variable which would be path in capital letters, and then the value of it is the directory where the Java C and Java tools are residing. So that would be C, program files, Java Jdk 1.8.0 underscore 51 slash bin, end with the semicolon, and then click OK, click OK, click OK, and then you can close this window. Now let's try to run this program. This works. Obviously we're in bin directory. Now let's try to run the same program outside the bin directory. So let's open up new command processor window. Now I type Java -cp for class path, C, users, admin, desktop, then first app. Cool, we're seeing this message. This would not have worked without setting the path variable. So when we specify the word Java or Java C, operating system tries to search this tool in the current directory, which in this case would be admin. If it is not there, then it will refer to the path variable that we have just set. And whatever the path that we give in path variable, it will go and look into that particular directory. And hence, we got this tool working even though we're away from the bin directory. In this chapter, we'll talk about variables and data types. Take a look at these equations in math. Now, a question for you. What can I do to these equations so that I can improve the readability and decrease the amount of physical effort required? It's simple. I would just represent these numericals with letters. So maybe I would just call this numerical as A, and I would call this numerical as B, and this as C. Now let's see how the equations look after replacing numericals with letters. So this is how they look. Now the equations look a lot cleaner, more readable. Also down the line, if you want to write hundreds of other equations, you don't have to remember the numericals. You can just use the letters instead. So that will save a lot of physical effort as well. So what's a variable here? A is a variable here, B is a variable here, C is a variable here. So from this, let's try to form a definition of a variable. A variable is something that holds a certain data. In this case, the variable a and b are holding numericals, the decimal numbers. Now let's understand variables in Java. We have our first app program. Let's use the same program and make some amendments to it. So now what I'm going to do here is I'm going to find the sum of two numericals. So let's say we have a equals 10 and b equals 4.3. To do the sum of these two numericals, instead of displaying this message, you would just say a plus b. Now if I try to compile this program, the compiler will throw some errors. Let's see what those are. Let's open the command processor and go to the directory where your program is residing. It's in desktop. Let's do CLS to clear the screen. Now let's try to compile the program. Java C, which is a Java compiler. First app.java. So the compiler has thrown some errors, which says it cannot find symbol and it is pointing to letter A. Same is the case with letter B. Alright, what's going on? Java is not a human being. It's a computer. It's artificial intelligence. And we humans, we programmers need to be more specific about the information that we're providing to a machine. By that I mean, it's just not enough if you say A equals 10 or B equals 4.3. We also need to tell Java what type of data this A is holding. In this case, it's integer in case of A. In case of B, it's a decimal point numerical. So the keyword that we need to use for integer in Java is int. This tells Java that the variable A is holding a data of type integer. Now for decimal point number, the keyword that we need to use is double. One thing to note is like I've already mentioned, Java is a case sensitive language. So instead of double, if you say capital D double, then this would yield a different result. Or if you say DO, if you make O as capital, then this would yield compilation errors. So let's not do that. Let's give it as double. And let's save the file. I just hit Ctrl S. Let's go to command processor again and try to compile the program. The program got compiled successfully. Now we also have a class file here to run the program. Let's do CLS to clear the screen and then now let's just try to run the program. So Java space first app. Let's hit enter. Great. It has shown the output 14.3, which is expected. Now to make this output look a little bit more meaningful, let's try to prepend a string before the result. So instead of just saying A plus B, what we do is we'll write a string which says the sum of A and B is the result. Now there's one more thing to note here. The character plus, in case of A plus B, it is used to find the sum of these two numericals. But the plus in here is acting as a concatenation operator, which means it is concatenating what's there in the left and what that comes in the right. Now if you try to run this program, you'll see a strange output. Let's see what it is. Let's compile the program and run it. The sum of A and B is 104.3. What has happened? It's supposed to be 14.3. As I said, the plus character serves two purposes. One, it acts as a concatenation operator. Also, it can be used to find the sum of two numericals. In this case, Java got confused to determine whether this is a concatenating operator or to find the sum of two numericals. So what we want is we want this plus operator to be a concatenating operator and this plus as a plus operator in math. So we need to put them in parentheses. Now let's just try to run the program. Compile the program and then run it. Cool, now it's displaying the correct result. The sum of A and B is 14.3, which makes sense. So a variable has the following syntax. The data type, which defines the type of data, like integer, and the name that you want to give to the variable, something like this, and the value, actual value, that this variable holds. Now let's try to understand what happens behind the scenes when we say int a equals 10. So when we run the program and when the interpreter comes across with this instruction, it will create a memory location to store the value 10. And how would this memory location be identified? With an identifier, which is a in this case. So variable in essence is nothing but this memory location. So down the line, if you do a plus b, the interpreter tries to look at the memory location with an identifier a and get the value inside it and replace this letter a with 10. So behind the scenes it does 10 plus, let's say, 20. Now we have different types of variables in Java, but at this point of time it is way too advanced. After we cover the concepts of classes and methods and a few other topics, we'll definitely be getting back on these variables and we'll explore even more concepts. Now I said a certain memory is allocated, but how much is dependent on the type of data. In case of integer, it's going to allocate 4 bytes of memory. In case of double, it's going to take 8 bytes of memory. Our next lesson is dedicated to understand how much memory does each data type take and their ranges. For example, you can't just give 10 zillion number here. There's a certain range within which the number has to be. In our previous video, we've talked about variables and data types. Now in this video, we'll understand how much memory does each of these data type take. We've already talked about integer data type. It takes 4 bytes of memory. Just for your information, each byte would constitute 8 bits. And a bit is the smallest unit of memory in computing world. And the value can fall in within this range. For example, int a equals 100 is valid. Int a equals 100,000 millions is not valid. The number has to fall within this range. Short is a shorter form of integer and it takes half the memory what integer would take. It just takes 2 bytes of memory and its value can fall within this range. Byte takes the shortest memory of all numerical data types and you can have a number within this range. This range actually makes sense given the fact that it just takes 1 byte of memory. As I said, 1 byte would constitute 8 bits. So with 1 byte you can have 255 combinations of zeros and ones. So hence the range is 128 to 127. Same is the case with all the other data types. Now long takes 8 bytes of memory and you can have a number within this range. In most of the cases you would either use integer or short, and only in rare cases you would ever use long. So why do we have 4 different integer types? The problem is the performance. It's because if you have to use a variable that holds a value within this range, maybe let's say the value 120, then if you use long for that, it occupies 8 bytes of memory. Whereas if you use byte, it would just consume 1 byte of memory. In case of high-end applications, memory is very precious. If you keep using long, even though it is not necessary, then it would degrade the performance of your application. We've already talked about double data type. It consumes 8 bytes of memory, and it can have a decimal number within this range. Essentially what this means is, in simple terms, you can have up to 15 decimal digits, which means the numbers that come after the decimal point. Float is a shorter version of double, and it just consumes 4 bytes of memory, and you can have a decimal number within this range. Essentially, you can have up to 7 decimal digits. We have a couple of other data types. Boolean is a data type that holds only 2 values. There are only 2 possible values that a Boolean can hold. One is true and the other is false, and it just consumes 1 bit of memory. Actually, it's not reasonable to say it takes 1 bit of memory. It's actually dependent on few other factors, one of which is the JVM that you're using. But typically, let's assume it just takes 1 bit of memory. Char data type is a single 16-bit Unicode character. It consumes 2 bytes of memory, and number has to fall in within this range. This might confuse a little bit for you because we're talking about character. Character can be letter A, an uppercase A, or lowercase x. But how come we have numbers, numericals here? In order to demonstrate the data type char, I already have a program written. Let's go through it. If you take a look at the character variable C3, then it's just holding a single character. In this case, it's A. But character data type can also hold a numerical. If we try to print C1, it won't print 76. Instead, it would print a character which is corresponding to this Unicode. For example, for 76, the character that is corresponding to this is letter L. And for 40, it is the opening parenthesis. Let's run this program so that we'll understand more. Let's open the command processor, go to desktop. That's where my program is residing. Let's do CLS to clear the screen, and do Java C char.java. Let's run it. So let's see what has happened. The char for Unicode 76 is L. So this is the instruction which prints that. The char for Unicode 76 is C1. So it just retrieved the letter corresponding to Unicode 76. Same is the case with C2. Char for Unicode 40 is open parenthesis. Now for C3, we're just simply displaying what is there here, the letter A. Now here is the interesting part. The plus plus is an increment operator. Soon we're going to discuss what this is. In this case, what it is doing is, for C3 character A, if you do C3++, it will just increment the Unicode of A by 1. By that I mean the Unicode of A is 65, and it will increment it by 1, so it will be 66. And when we print C3 now, it would print the character corresponding to the number 66, letter B. In our future examples, we would definitely be using this operator again and again. I'm sure that you would feel much comfortable with this. Now, one more thing to note is the Unicode character set has, like I mentioned, it has 65,000 numericals, so that means there are 65,000 plus characters as well, which means it supports all the characters in most of the popular languages. Now, if you give a number, something like 30,000, 60,000, something like that, now the character corresponding to it may not get displayed in the command processor. It's because the command processor does not support all the characters. If you have much advanced GUI interface to run this program, maybe something like Eclipse or something, then you can probably display the output in most of the popular languages like German, French, Latin, etc. Alright. Data types is a pretty vast concept in Java. And whatever we have discussed in this video are just primitive data types. And when it comes to non-primitive data types or object data types, it's pretty vast. That being said, don't get terrified. We're going to cover everything in detail, and I'm sure that I'm going to make you feel comfortable. But for now, these are called primitive data types, and I believe now you have a fair idea on what these are. Sometimes it's the problems faced by developers or programmers which will introduce new features. Same is the case with arrays. Let me explain you what I mean. Take a look at this program. What we're having is we're having the salary details of 10 different employees of a company. For example, Ron earns $10 million and Krish earns $12 million. Obviously, no paying job would pay you so much whatsoever, but for example's sake, let's assume so. Now, let's say I wanted to find out the average salary of all these employees. The formula that we need to use is sum of all the salaries of all the employees divided by the number of employees. So I would do Ron plus Ben plus Liber plus Krish plus blah 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 divided by, and then the count 10. Let me just make sure it is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sorry, it's 11. So here is the problem. It is pretty tiresome for me to write, and it's even more tiresome for you to listen. Also, let's say we have some hundreds of employees here, and we need to give a proper count here, which is painstaking process. If I give an incorrect count, then that would yield a very bad result. So how do we solve this problem with arrays? Let me pull pen and paper and let's see a real-time example of arrays. Alright, let's say you own a transportation business and you specialize in transporting cars. So now you got a requirement where you need to transport 10 cars. Now we have a source and destination, which is where you need to transport the cars to. Now you'll start by sending all the cars on the road, car C1, C2, C3. Now the problem is it's pretty difficult to keep track on each and every car, make sure it is safe, take care of all the fuel expenses and potential physical damage to the car, etc. There are a lot of things to be considered, and it's pretty hard to manage. What if one of the driver just goes away with the car, not taking to its destination? Pretty tough. So how do we solve this problem? Instead of hiring 10 different drivers and managing 10 different cars, you would just hire one truck. Let's call this truck as truck T. And this truck has a certain capacity. Let's say it has a capacity to hold 12 cars. And each segment or each section will be identified with an index starting from 0. So the first section can be accessed with 0 index, and the second with 1, the third with 2, the fourth with 3. Now once you load all the cars into this truck, and once it reaches to the destination, you can pull a certain car using the index. For example, if you say T0, that would pull the car inside this segment. If you say T3, that would pull the car in the fourth segment. So that's exactly what arrays in Java. Let me go a little bit more technical into this. When you say int a equals 10, as I've already mentioned, this would create a memory size of 4 bytes and store the value of 10 in this. And this memory location can be accessed with an identifier called a in this case. And if you have 10 another integer variables, you would create 10 another memory locations, each of 4 bytes. But whereas if you create an array, it would just create one memory location, one big chunk of memory location, something like this. And whatever the size that you specify while creating the array is the number of segments it contains. And each of these segments can be accessed with an index starting from 0. Now if you want to pull the value inside one of the index, you would access it using the index. If you want to pull the fourth element, you would use index 3. Now let's apply this on our code and let's see how we can solve the problem. Let's get rid of all the code in here and start writing a fresh code. Now, the way we declare and initialize a variable is, by the way, we didn't talk about declaration and initialization. We will in a while. But to declare and initialize a variable, we say int ron equals 10. Now, to declare and initialize an array, all you would do is to add a square bracket here. Now, we can't give the value 10 here. We need to use a keyword called new, and then the data type, which in this case it's int, and then remember I talked about segments? That's what you need to give here. You need to tell Java how many segments of memory would you be requiring. Let's say 10. Now we have an array created. We have 10 memory locations created. All we need to do is insert values in each one of the segments of an array. So to insert a value in the first index, what we need to do is you just say ron at 0 index. Let's change the name ron to something meaningful. Let's call it array. Let me change the name here as well. Array of 0 index equals 10. Array of 1 equals 20. In order to save your time, let me just finish all the typing and then I'll get back. Okay, here we are. Now all you would do to find the average salary is this. Now please note that you may not be able to understand some of these instructions. When we cover the concepts of control statements, classes and methods, you would better understand these equations. We'll definitely be getting back on this example and we'll make you understand. But just for the explanation's sake, what we're doing here is we're just looping through each and every individual item in this array, and then we are adding each other. By the end, we're having the sum of all the elements. And in here, what we're doing is we're getting the sum divided by the length of an array. Going back on the problem statement we had to count each and every individual variable and type the exact count here. But in here, you can just say array.length. So this would just take the length of the array itself. So in here, we're just printing the average. Let's try to run the program. Cool, it displayed the average salary. Now the key thing to note here is we gave the size as 10. If you just fill only 5 of them, we would still be having 10 memory locations. So when we do array.length, it actually gets the size of an array, which is 10, regardless of number of segments that were filled. So that's one of the primary disadvantage of using arrays. You have to know upfront the size of the array that you're going to use. Otherwise, most of the memory will be wasted. The point that I want you to take away from this is, let's say we have thousands of employees. You don't have to type in each and every variable. Instead, you can just have the similar lines of code which would do the magic. This is just one simple example of array, but this does not actually explain the real advantage of arrays. To know more on arrays, we need to cover the concepts of classes, objects, methods. Also, we need to go through the control statements to understand better. But for now, this should suffice. Now let's quickly talk about declaration and initialization. By the way, we can further shrink this code and reduce the number of lines by using curly braces. So instead of giving a fixed number of 10, and entering each and every value in this manner, we can just simply get rid of this and get rid of this as well, and simply use curly braces and give the numbers or the values separated by comma. Something like this: 10, 20, 30, 40, 50. Now the size of array dependent on number of values that you give here. Now this statement makes more sense, and this would never go wrong. Now let's try to run the program again. Cool, we got the average. So it's working. Okay, now let's see declaration and initialization. As I have already mentioned, we have two different types of data types. One is primitive, other one is non-primitive or object type. In case of primitive data type, like int equals 10, this is the declaration part, and if we assign some value to it, that's called initialization. So when we say int a, we will create a memory location with a as identifier, and we would have a default value of 0 regardless of initialization. So even if you don't say a equals 10 or something, we would still have a memory location created. But that's not the case with non-primitive data types. For example, in case of array, if you say int square brackets array, this is just a declaration of array of integers. This would just tell compiler that we're creating an array of integers. Unless you use a keyword called new, no actual memory will be allocated. So you need to say array equals new int of certain size. Then this would just create 10 memory locations, and each memory location would be of size 4 bytes. So this part is called declaration, and this is called initialization. Now let's go back to our workbench and see a few other examples. Now in this example, what we're doing is we're just sorting all the values of an array in ascending order. So the function, the method, by the way, method is synonymous to functions in C language. And once again, we'll talk about methods and classes, and more specifically on this operator over here, the dot. But for now, just think of this as a function in C language, and it takes some value and do some processing. In this case, it just takes array and it
sharing, the audio channels were like, I guess, taken. don't even remember this. This is so old. I fast forward through some of this shit. folder of icons I would like to export into Excel as pictures, spreadsheet, a bunch of icons. What would be the best way to do that?